Hello, all my dear students. I welcome you all to Chickadee Academy. In today's session, we are going to discuss the most awaited and the most scoring topic from array optics, which is called optical instruments. One question is fixed from this topic in your board exam every year. It can be a straightforward question where they ask you to define the optical instrument. It can be a simple microscope, it can be a compound microscope, it can be a telescope. In telescope also, we have two types of telescope, reflecting and refracting. So they may ask you to draw the ray diagram, explain the construction, working, and derive the magnifying power ka expression. Or it can be a straightforward numerical also. So in today's session, we are going to discuss how to draw the ray diagram, what is the construction, how is the working, and how to derive the expression for magnifying power. I will put one more lecture on this in which we will discuss some previous year questions where I will discuss the numericals based on this optical instrument. The first optical instrument what we have is simple microscope. In simple microscope, we will be using simple convex lens, only one convex lens. And what will this convex lens do? Whatever is the object kept in front of it, it will magnify it. As you can see the definition, a simple microscope or a magnifying glass is just a convex lens of short focal length held close to the eye. It is held close to the eye. So where is the object? AB is the object, right? And where is the image form? This is the final image form. What you can see here, A dash, B dash is your image. AB is the object, A dash, B dash is the image. Okay. Now, if you focus in the ray diagram, it is just basic ray diagram of convex lens. Object is kept, take two rays, correct? And the image will be formed at this point, which is A dash, B dash. So there's nothing special in the ray diagram. It's basically your grade 10th basic ray diagram. Now, when you see that there are two angles here, alpha and beta, let's understand about that. So what is alpha? If you see the angle alpha here, I join the center to this point. Which point? A double dash B dash. The height of A double dash B dash is same as the height of the object. So you can think that I have taken a replica of the object at this point. Correct? If I join the point O to this A double dash B dash, the angle formed is alpha. If I join the O to the image A dash B dash, what is the angle form? B. What I'm trying to say here is that alpha is the angle formed by the object kept at D. If the object is present at D, D means least distance of distinct vision. If the object is present at D, angle formed by the object is alpha. If the image is formed at D, the angle formed by the image is B. Simple. And that's what is the definition of magnifying power. If you see that, what is magnifying power? It is denoted by small. Is the ratio of the angle formed by what? Image divided by ratio of the angle formed by object when both of them are present at least distance of distinct vision. Since these angle alpha and beta are small, so the angle will be approximately equal to tan beta or tan alpha. This is the basic of trigonometry. Whenever angles are small, the angle will be approximately equal to tan theta or sine theta. So here we are taking tan theta. So what is the definition of magnifying power? Tan beta by tan alpha, or you can say ratio of the angle formed by the image and object when both of them are present at least distance of distinct vision, which is. So let's modify this expression. Okay, let's modify this expression. So the definition I've written, you can add the ray diagram and the definition in your notes. Let's derive it. Okay, so if you see the figure, what is tan alpha from this figure? All of you see here, what is tan alpha? So tan alpha, if you see, tan alpha will be A double dash B dash divided by D. Correct? Tan alpha will be A double dash B dash divided by D. So let's write down A double dash B dash by D. Right? Now, what is tan beta? For tan beta, I want you to focus in the small triangle. For tan beta, I want you to focus in the small triangle. So what is tan beta? AB divided by X, where X is the object distance. So tan beta is AB divided by X. So for magnifying power, we need to divide both. Let's divide both. So M equals to tan beta by tan alpha. So let's divide both. If you see in the figure, A double dash B dash and AB both are exactly same. You can see in the figure, AB and A double dash B dash are parallel to each other. They are equal. When I divide, they will get cancelled. So this will get cancelled. So what it will be? 1 by d divided by, sorry, it is tan beta, right? Sorry. So this will be what? Tan beta. So AB and A double dash beta gets cancelled. So this is 1 by x divided by 1 by d. D will move up. So it will be what? D by x. So this is the magnifying power of a simple microscope, d by x. We can still modify this by using lens formula. So what is the lens formula? 1 by v minus 1 by u equal to 1 by f. Students, where is the image formed? Image is formed on the same side of lens, right? Same side of lens in the sense, left side, what I'm trying to say, not same side of lens. It is formed on the same side of the object, correct? So if you see here, where is the image formed? Image is formed on the same side of the object. So this d, which is image distance, will be plus d or minus d? Minus d. This u will be plus x or minus x? Minus x, because it is on the left side, opposite to incident ray. Okay, students, let's use the lens formula. 1 by v minus 1 by u equal to 1 by f. Let's substitute the values. Minus 1 by d, and then u is minus x, correct? So minus minus becomes plus. This will be 1 by x. I will move 1 by d on the other side. So 1 by x equals to 1 by d plus 1 by f. Now, if you see the expression, I need d by x, right? Magnifying power is d by x. So I will multiply by d in the whole equation. So this will become d by x, d by d1. This will be d by f. In this equation, I am multiplying. In this equation, I am multiplying throughout by x, not x, throughout by d. This becomes d by x, d by d1 plus d by, and d by x is magnifying power. So the magnifying power for a simple microscope is 1 plus d by f. When the image is formed at d. There is one more condition in this. What will happen if the image is formed at infinity? Very simple change you have to do. Very simple change. If the image is formed at infinity, just remove this one. So if the image is formed at infinity, if the image is formed at infinity, what will be the magnifying power? D by f. Simple. So this is the magnifying power for a simple microscope when the image is formed at least distance of distinct vision. Derivation should be on your fingertips. They can ask you the derivation with the definition of magnifying power, and they can ask you a numerical also. So let's move to the next optical instrument, which is called compound microscope. In compound microscope, we will use two convex lenses. So you can say double the mark. Power of two lenses. So what will be the effect of power of two lenses? That the magnifying power will increase by, you can say, a big factor. Right? The magnifying power will be very high as compared to simple microscope. That's what I told, double dhamaka, two lens. So let's understand that how compound microscope works, what is the construction, and what is the magnifying power. Okay, students, let's discuss compound microscope. In compound microscope, we will have two lenses. The first lens is called objective, and second lens is called eyepiece. Why the first lens is called objective? Because that lens will be close to the object. That's why it is called objective. The second lens is called eyepiece because that lens will be close to the eye. Now, what you need to understand here is what is the difference between objective and eyepiece? Objective is also a convex lens, eyepiece is also a convex lens. In objective, for the compound microscope, the focal length and aperture will be a bit smaller as compared to the focal length and aperture of the eyepiece. Okay, so the focal length of objective and aperture of the objective is a bit smaller as compared to the focal length and aperture of the eyepiece. Okay, and why it is called objective? Because it is close to the object. Why it is called eyepiece? Because the second lens is close to the eye. There is one more name for eyepiece. Eyepiece is also called ocular. Eyepiece is also called ocular. Okay. Now, the next most important thing is the definition of magnifying power. Again, what will happen? Magnifying power will be the ratio of the angle formed by the image divided by ratio of the angle formed by the object. That is beta by alpha or tan beta by tan alpha. And that's what you can see the definition here. The magnifying power of a compound microscope is defined as the ratio of the angle subtended at the eye by the final virtual image. So angle formed by the image at the eye with respect to the angle formed at the eye by the object. And both object and image should be present at what? The least distance of distinct vision. So let's derive the expression for magnifying power by first understanding that what is a ray diagram. Okay, students, let's discuss the ray diagram. What you can observe in the ray diagram that we have two lenses, objective and eyepiece. The focal length and the aperture of the objective is a bit smaller as compared to the objective and eyepiece, objective and aperture of the. If you see the ray diagram, how the ray diagram has been drawn, quickly understand. Object is in front of the objective. The image of this object is formed here. So A dash B dash is the image of B. So this is the image of object. The image of the objective will act as a object for the eyepiece. The image of this is the object for eyepiece. Two rays coming from the object forming an image here. Then two rays coming from this and reaching the eye. When you extend these two rays, in the backward direction, because in the forward direction they are not going to meet. In the forward direction they are not going to meet. We need to extend them in the backward direction and they are meeting at this point. So this A double dash and B double dash is your final image. And see the magnification. See the final magnification. See the length of A dash B dash as compared to, A double dash B double dash as compared to A dash B dash. Magnification has been increased, right? Magnification has been increased, and that is the power of two lenses. First, this lens will magnify, and then the second lens will magnify it further. Okay, so is the ray diagram clear? The image of this lens is acting an object for this. In the forward direction, you can see that they are not going to meet. So we need to extend them backward. That's why the final image formed is virtual and inverted. Now you will ask, sir, virtual is always erect. Why virtual is inverted? Because our object itself is inverted here. With respect to this, image is also inverted. And why it is virtual? Because in real, they are not meeting. We have to extend them in the backward direction, and then it seems that they're meeting at this point. Therefore, it is a virtual image. So they can ask you what type of image is formed by a compound microscope, virtual and inverted. Okay, what type of image is formed by the objective of the compound microscope, real and inverted. Okay, let's derive it. Let's derive the expression for the magnifying power. So first of all, m is equal to beta by alpha, which will be same as tan beta by tan alpha. So beta is the angle formed by the image, alpha is the angle formed by the object. Correct? So let's find out tan beta and then find out tan alpha. So object should be present at what point? D. That's what was the last statement. That object and image both should be present at D. I took the object to be at D. And what is the angle formed by the object when the object is present at D? Alpha. From this simple figure, what can you understand alpha as? Tan alpha will be h by d. I'm assuming that object is present at D because that's what is the definition. Object should be also assumed to be at D. Then what is the angle formed with respect to I? That is alpha. So tan alpha from this thing, I've drawn this separately. If you don't want to draw this separately, you can see from this figure also, but it will be a bit confusing. That's why this figure is required. So what will be tan alpha? Tan alpha will be h by d. Correct? Now what will be tan beta? If you see in this figure, this one. So take this smaller triangle. So tan beta will be equal to how much? A dash B dash divided by UE. What is UE? Object distance for the eyepiece. What is UO? Object distance for the objective. Correct? Now, what is A dash B dash? H dash. H dash by UE. What is H dash? H dash is the height of the image by the objective. Now, divide both. So when I divide both, what will be the magnifying power if you divide both? Tan beta H dash by UE divided by H by D. So when you simplify this, what will you get? H dash by H into D by UE. Or just observe one simple thing. What is H dash by H? Height of the image of the objective divided by height of the object of the objective. Image by object for the objective will be magnification of the objective into D by UE, D by X. Let's go back to simple microscope. Remember that magnifying power was D by X. So this eyepiece will act as a simple microscope. First, objective will magnify the object, and then this will act as a simple microscope. So this will magnify it further. So what is the magnifying power of a simple microscope? B by x. So what is x? X is the object distance, which is UE. So this is indirectly magnifying power of eyepiece. So total magnification will be magnification of objective into magnification of or magnifying power of eyepiece. This is the first step. This is the first. Now we will move ahead. Now what we will identify here that how to identify the magnification of MO expression and MEK expression. Okay, students, let's write down the expression further. What can we write MO as? H by H, perfectly fine. But you can say that it will be also equal to image distance of the objective divided by object distance of objective. It will be V naught by U naught. Let's modify the expression of ME. If you remember in the simple microscope, what we discussed, that the magnifying power of a simple microscope is 1 plus D by F. So this eyepiece will work as a simple microscope. Once this image is in front of this eyepiece, and this image will work as an object for this. So this eyepiece will work as a simple microscope. So what is the magnification of a simple microscope? 1 plus D by F. You will write the focal length of what? Eyepiece. So D by Fe. So what is the final magnifying power now? V naught by U naught into 1 plus D by E. We will modify it further by taking some approximations. What is the first approximation? If you see in the figure, this V naught is almost, not exactly, almost equal to the distance between the objective and eyepiece, which is called the length of the tube connecting objective and eyepiece. So if this V naught is almost equal to the distance between objective and eyepiece or the length of the tube, we can say that V naught will be approximately equal to L, first approximation. And second is, if this object distance for the objective is almost equal to the focal length of the object, if it is, so what we can say that U naught will be equal to focal length of the objective, but it will be what? Plus sign or minus sign? Minus, because it is on the left side. So minus F. So by taking these two approximation, we can modify this further. So this approximation is not always true. Okay. If this is true, substitute. So magnifying power will be minus L by F naught in 1 plus D by Fe. This is the thing. So this is after approximation. The correct one or the core expression is this one. The method is simple. First draw the ray diagram. Then find beta by alpha. You will get this as the magnifying power, which is a product of magnifying power of objective and eyepiece. Modify this by using V by U. Eyepiece will work as a simple microscope, 1 plus D by F. Multiply both. After that, if you take the approximation that the distance between the objective and eyepiece is almost same as V naught, almost same. This total is almost. And the object distance for the objective is almost same as focal length. You can substitute and modify the expression. Okay. I hope that you guys have understood. Yeah, it's a bit lengthy, but you need to have patience and practice. See, practice is the key. Practice and patience. Don't think that you learn everything in one day. You need to have patience, but with consistency. With consistency, you have to move ahead. You will achieve whatever your goals are. Now, in this, a small modification that if the image is not formed at D, if the image is formed at infinity, then what will happen? Again, same thing. If the image is formed at infinity, you will remove this one. Simple. The magnifying power of eyepiece will be what? D by Fe. So no need to worry. For infinity, just remove this one from the magnifying power of eyepiece, and that will be your final answer. Let's move to the next optical instrument, which is astronomical telescope. Okay, students, now let's discuss the astronomical telescope. Now, astronomical telescope is basically a refracting telescope. There are again two types of telescope, refracting and reflecting. In refracting, lens will be used. In reflecting, mirror will be used. So in astronomical telescope, we will have two lenses again. One will be objective, other will be eyepiece. But here, what you need to make sure is the objective and eyepiece are same, but the structure is different. In this case, in astronomical telescope, the objective will have higher focal length and higher aperture as compared to eyepiece. It is exactly opposite of the microscope. exactly opposite of the compound microscope. Here, objective will have very high focal length and aperture as compared to the eyepiece. So if you see here, it is a convex lens of large focal length and a much larger aperture. Faces the object, that's why it is called objective. And why is the focal length and aperture needs to be more? Because parallel rays are entering. So we need higher aperture of the objective so that it can allow maximum amount of rays to refract or pass through. If maximum amount of rays will pass through the lens or objective, intensity of the image will be also high. So that is the reason the focal length and aperture of the objective should be large enough as compared to eyepiece. And that's what is written, so that it can gather sufficient light from the distant objects. Eyepiece, it is a convex lens, small focal length. So here, remember one thing, in telescope, the difference in the focal length of objective and eyepiece is huge. But in compound microscope, the difference in the focal length of objective and eyepiece is not that much. The focal length of the eyepiece is more as compared to objective, but the difference will not be huge. That I will show you in the next video, in which I will take some questions where they give you a table and they ask you which case will be suitable for a microscope or telescope. So make a note, in the telescope, the difference between the focal length of objective and eyepiece will be more. But in microscope, compound microscope, the difference between the focal length of objective and eyepiece is not huge. It's small difference, you can say. Okay. Okay. Now, the next, again, the definition of magnifying power. The magnifying power of a telescope is defined as the ratio of the angles subtended by the image with respect to the angles subtended by the object. When both of them, like this time, should both of them be present at the? No. No. If you read the definition, angle subtended at the eye by the final image formed at which distance? Capital D. To the angle subtended at the eye by the object at infinity, because this time the light rays coming from infinity. Correct? So object is present at infinity and image is formed at D. So the ratio of the angle formed by the image with respect to the object. So let's see the ray diagram and derive the expression for magnifying power. Okay, students, if you see the ray diagram, light rays are coming from where? Infinity. That's why parallel rays are entering. So what is the angle formed by the object with respect to the eye? You can see angle alpha. And what is the angle formed by the final image? So A double dash, B double dash is the final image. What is the angle formed? You can see beta. So we will write magnifying power. Magnifying power is what? Beta by alpha, which will be same as tan beta by tan alpha. Now let's understand how to find tan alpha and tan beta. If this is alpha, this will be also alpha vertically. Opposite angle, if this is alpha, this will be also alpha. So if I focus on this triangle, what is alpha or tan alpha? So tan alpha will be equal to A dash B dash divided by, what is the base? FO, F, focal length of object. Tan beta. For tan beta, I want you guys to focus in this smaller triangle. So what will be tan beta? A dash B dash divided by this much distance. What is this much distance? UE. UE means what? Object distance of eyepiece. I hope that all of you are clear in writing tan alpha and tan beta. Okay, very simple. You just need to know which triangles to pick. Now, if I find magnifying power, if I divide both, A dash B dash, A dash B dash gets cancelled. So tan beta, so 1 by UE divided by 1 by FO. So what will be the expression? FO by UE. This is the expression for magnifying power, but we need to modify. So how will I modify? I will apply the lens formula. This is eyepiece. Okay, students, if you see the expression for magnifying power, what is the expression? F naught by UE. Any mistake in this? Yes. UE will be negative. Object distance is negative. So when you are writing the thing, this will be what? Minus UE. Okay, you have to be a bit careful. You have to write down UE with their proper sign. Okay, don't forget that. This UE you have to write with their proper sign. Here also you can add minus UE, minus UE. Okay. Because UE is on the left side. Now, we will apply lens formula for eyepiece and we will try to modify this expression further. So if I apply the lens formula for eyepiece, 1 by V minus 1 by U equal to what? 1 by F. We are doing for eyepiece, so this will be what? FE. Right? Now, what is the object distance for the eyepiece? So minus UV. It is on the left side. So this will be minus of 1 by minus UV. Now, what is the image distance for this? This image is formed on the left side. So V will be plus D or minus D? Minus D. It will be minus D. So we have minus 1 by D plus 1 by UV equal to 1 by FE. So from here 1 by UV will be what? 1 by FE plus 1 by D. Now we will put 1 by UV here. Since magnifying power is minus F naught into 1 by UV, right? So put 1 by UV here. So minus F naught into 1 by Fe plus 1 by D. We can take common. What we will take common from here? Fe. I will take Fe common from this bracket, or you can say I will multiply and divide by Fe. Anything is fine. I will multiply and divide by Fe. So if I multiply and divide by Fe, it will be minus F naught by Fe. Now multiply by Fe, this becomes 1 plus Fe by D. This is the final expression for magnifying power of an astronomical telescope. Okay, students. So I will quickly explain the flow. First, I wrote magnifying power, beta by alpha, tan beta by tan alpha. We saw in this triangle to find alpha, this triangle to find tan beta. Don't forget to write UE with negative sign, okay, because it is on the left side. Got this expression. Then you finally apply lens formula for eyepiece. The moment you apply lens formula for eyepiece, you can see that you got the expression for 1 by UV. Why I'm finding 1 by UV? Because 1 by UV is required here. Substitute and then finally multiply and divide by Fe to get the magnifying power of a astronomical telescope. I think ray diagram should be clear. There should not be any problem for ray diagram, right? Parallel rays coming. If parallel rays are coming after refraction, where will they meet? Focus. So you can see that image of objective is formed at basically FO, focus. And that will act as the object for the eyepiece. And this is the final image. If you see that our final image is what? Virtual and invert, right? Inverted with respect to our original object. But if you see, the image of this objective is also inverted. So the final image is also inverted. But with respect to the original object, what is the image? Inverted. Huh? Okay, student, what is the next? Normal adjustment. What is the meaning of normal adjustment? Means the image is formed at infinity. No, very simple. If the image is formed at infinity, right? So how will you modify the expression for magnifying power? Basic definition remains same. Beta by alpha. Since angle is small, tan beta by tan alpha. So the definition of magnifying power is what? Beta by alpha or tan beta by tan alpha. For tan alpha, which triangle will you pick? This triangle, right? So what is tan alpha if you see? Opposite by base. So tan alpha will be equal to A dash B dash divided by FO. Now for beta, which triangle? This triangle, right? For beta, which triangle? This triangle. So it will be what? A dash B dash divided by FE. Again, you have to be careful here. The image for this eyepiece is formed on the left side, right? On the left side. So since the image is formed at infinity, right? Since the image for the eyepiece is formed at infinity, where should be the object for the eyepiece? At its focus. When the object is present at the focus of a lens, where is the image found? Infinity. So the object distance for the eyepiece will be same as the focal length of the eyepiece, right? Again, it should be with what sign? Minus, because it is formed on the left side with respect to the lens. So minus Fe. That thing you need to take care of. This gets cancelled. So what is the expression? Minus Fo by Fe. If you see it, it is exactly same as the expression for the magnifying power of astronomical telescope when the image is formed at D. Here it was UE. If you remember the previous expression, here it was UE. But in this case, the object distance of eyepiece should be the focal length of the eyepiece. Then only final image will be formed at infinity. So UE is replaced by Fe. No need to modify this. This is the final expression. In the previous case of astronomical telescope, we modified the expression by using lens formula. So let's move to the last slide, which is basically your reflecting telescope. Okay, students, as you can see the structure of the reflecting telescope, in this this is the objective mirror and this one is the piece. Okay, derivation is not in your syllabus. Derivation for the reflecting telescope is not in your syllabus. You should just know the structure and you need to know what is the advantage of reflecting telescope over refract. Okay, but still I'm writing the expression for the magnifying power. So the expression for the magnifying power when the image is formed at D is FO by FE into 1 plus FE by V. When the image is formed at D. If the image is formed at infinity, if the image is formed at infinity, then it is only FO by, and it is very easy to remember because the nature of the expression is exactly same as of refracting telescope. Only thing what is missing here is sign, negative sign. In the refracting telescope, if you remember, there was a negative sign extra here when the image is formed at D. There was an extra negative sign here when the image was formed at infinity. So it is very easy to recall the formula if you remember the expression for the astronomical telescope, which is basically your refracting telescope. These are few advantages of reflecting telescope over refracting. They can ask you MCQ or they can ask you a assertion reason or they can ask you a 2-marker also, that write the advantages of reflecting telescope over refracting, or they can tell which of the following statement is not correct. So you need to know few advantages of reflecting telescope over refracting telescope. There's nothing for me to explain in these points. You can add these to your notes. So this is how we sum up the optical instruments. We started with simple microscope, compound microscope, then refracting telescope, and then reflecting telescope. So these are the 4 main, you can say, optical instruments in your syllabus. In the next lecture, we will discuss some previous year numericals, not the theory, numericals on this topic. And do let me know in the comment box what is the next video you want me to come up with. To prepare properly for your board exam, Chakru Academy is with you guys.